Hi there, Physics Lab. I'm Dan Ludwigson. I'm here to talk about graphical analysis just a little bit and see if we can get things rolling with this new software tool. So when you open up graphical analysis, I think you're going to see a screen somewhat like this guy right here. There's a splash screen. Now, the first time you open it, it probably won't have this licensed to bit. You're going to have to enter the code for our license in order to get this Graphical Analysis Pro version. The free version has a fewer features than what we want to use. So let's close this splash box a little bit and open up, well, just to check things here, that's how you would get the license key in there. Just go to the three dots and click About, enter your license key, and then hit Submit, and that should do the trick. So when we first open this up, what we'd like to do here is create a graph, just manually inputting some data. We'll advance to how to use sensors in just a little bit. But for right now, let's just start to use the software. If you want to use manual entry, we need a data table. So let's start to input some data, like maybe 0.1 and 0.2 and so on. I'll fill in some fake data here. Let's see, maybe just make up some numbers. And okay, so there's some data. And once we have that data input here, we don't really need to focus on the data set per se, but we do want to see the data on the screen. So we want to select which data we're going to use here. I think just turning that off and turning it on does the trick, and we'll get the data to show up here. Now, this is not preferred for this kind of data. We've got discrete data. We've got information at certain points. So at point 1, we know it's 1 unit high. Well, these dot-to-dot lines, they're okay to show a trend, but they don't really show the discrete nature of this. So what I'd like to do is I could change column options here to adjust some things, but what I really want is down here in these graph options. So I'm going to edit the graph options and do not use a title. We can capture everything we need in terms of information for the graph in a nicely formatted caption, so I avoid titles in my graphs. And the appearance here, I'm going to switch from lines to points. So I'm going to add points. And I also want to adjust this and make sure that I get the 0 on the x-axis in here, otherwise it's automatically scaled. Okay, so this turns out to make a graph kind of like what we would expect. Now, a lot of what we're going to do in physics is going to take the measured data, the experimental results, and we want to see a trend in there. So the next task that I want to do is to add a curve that's fitted to the data. So we could go in here to these graph options and take a look at statistics. We can integrate the data, find the area under the curve, but what I want is the curve fit. So I'm going to start off here, and it by default gives me a linear fit. Well, that doesn't really seem to do a very good job for this particular data. I'm going to say, well, what about a quadratic fit? That's a little better. A power law fit, where x is raised to some power with some coefficient a out in front. That's nice. I'm going to put ax raised to the power of b plus c here, and I'm just going to use that as a different type of fit. So we can insert our own custom fit as well. And then it fits this to the curve using some statistics, and we'll talk a little bit more about that as needed in lab. And then it gives you the information out here in this box. So the parameters that we're using, the coefficient A, the power B, and then this adjustable offset C is fit to the curve. Now the root mean squared error is also given. That's a goodness of fit measurement. And the root mean squared error, the lower that number is, the better. Lower compared to what? That's a question for discussion later. But that's how you get a manual fit to data that you enter in your data set in your table over here, and then apply a curve fit. Now let's say we wanted to use this graph in a report. So we could go up here to the, we'd actually save this file as a graphical analysis experiment file. But what I want to do right away is export the data. And if I export the graph as a PNG file, a graphics file, you can adjust some of the options here, but I'm just going to go ahead and save that as a PNG. You can also copy it to the clipboard, which is great if you've already got a Word document open or whatnot, and you just want to paste it in. It'll usually work out pretty well there. So you can save this as a file, and in our first week of lab, I'm going to ask you to do this with your last name. So you might type your last name in here and then hit save, and boom, there you go. You're all set.